Yes. So today we are just going to work through any problems that you might have, whether it be from the homework or any hawks from past sections, or anything on the review or whatever, because again, we finished all of our new stuff and today's just practice, ask your questions, whatever. Tomorrow, same thing really. We could go over the review, go over whatever you want to go over, and then that's it. So Ashley, do you still want to look at that one, or do you feel comfortable with the answer you got without using the LN?
I feel comfortable with it without now. I mean, didn't do it with the Ellen, and I was like, huh, I wonder if that was correct or not, if I was supposed to use Ellen.
Yeah, so on that particular one, you could actually have used the LN and gotten the same answer. But since both bases could be changed to 6, that was the quicker, easier way to go. So if you got the answer that I showed on Blackboard, then you're good to go. All right, so I kind of want to open this up for a minute to just kind of, what do you guys want me to do? What do you want to look at? Okay, we've gone through all the sections. You've worked on, hopefully, all of the support assignments you've at least looked at. The review has been out there for several days, as well as extra practice. I did not take the Hawks, the availability. I didn't take it away. It's still available if you happen to want to look at it or whatever. There were some optional practice tests in Hawks, anything. So someone shoot a couple problems from 7.3. Okay. So let me get my 7.3 stuff out here and we will do that. Do you have a preference on what kind, or just kind of a refresher all over? A refresher. Okay. So let me get my whiteboard out here, and these problems aren't necessarily written down anywhere. They're just problems that I brought with me today so that you guys could have the option to ask me questions. So you can write these down, you can watch, ask your questions, whatever. So let me get my whiteboard up here and we will look at some stuff from 7.3. Okay, so 7.3. All right, so in 7.3, this is the section where we first learned about logs. And we learned, first of all, how to write them in log form and exponential form, things like that. And we learned in this section how to actually go about solving them. And so I'll do a couple problems like that gently, so to speak, and then we'll kick it up a notch. And we'll bring in the LN, we'll bring in some actual equations and things like that. So let's just start. What if we had, a lot of you had questions on a problem like this. There's one like this on the worksheet for homework, and a lot of people said I wasn't sure how to do this. So if we have log base 32 of x, and that equals 2/5, and the instructions here are to solve. And so all we're trying to do is solve for x. So my answer needs to say x equals blah, blah, blah. Well, this is in log form. And so in order for me to solve this, I have to put it in exponential form. I have to draw my arrows. So I'm going to start at 32, hit the 2/5, cross the equal sign, hit the x. I will rewrite this as 32 to the 2/5 equals x. And most of you got here and then you put a question mark because you said, man, I don't know what to do. Okay, well, all we're going to do is get our calculator out and we're going to type in 32 and we're going to raise it with our little caret button, and we might have to put parentheses around these, I'm not sure, but we're going to raise it to the 2/5. And when we do that, we're going to get the number 4. So if you were one of the folks, many folks actually asked me about this question. If you were one of the folks who asked me about this question, do me a favor. If you have your calculator handy, get it out and type in 32 and raise it to the 2/5, hit your enter, and make sure that you get 4, because that's it. All right, let's do another one just to make sure. So what if we have, let's say log base 12 of 144 equals y. And again, I'm asking us to solve. So the first thing again that we need to do is to draw our arrows. And that's going to give me 12 to the y equals 144. And we're going to solve this without a calculator pretty easily. 12 what gives me 144? 12 to what power? Just 2. So done. Okay, so those are the types of problems when they're logs and we're trying to solve them. Well, what if, let's say we have, let's see, how about, all right, so then let's kick it up a notch. All right, let's make these problems just a little more interesting. Let's say we have Oh, goodness. I don't know. Let me get a good one here. All right, this is another one that I think a few people had an issue with. So let's do this one. How about, yeah, we'll condense them, not to worry, yes. Let's say that we have the ln of 3x plus 3. This is another one on the worksheet that a lot of you kind of were like, I don't know what to do. And the question is solve, and we know that when we have solve, we need x equals something, okay? And so in this particular problem, we know that we have it in log form because we see the ln, which means a log of some sort, but we don't have anything down here, so we can't draw our arrows. And so what we have to do is we have to take this particular issue, or take this problem, we have to say, okay, well, when I have the ln, that's actually log base what? E. And then the rest of this stuff, 3x plus 3 equals 2, that hasn't changed. And now I have a base, and I can draw my arrows. And so what I'll come up with is I will have that, let's see, e squared equals 3x plus 3. Now we've talked about e, okay, meaning this is just a button on our calculator. So for right now, I don't want to do anything with him. My only goal right now is to get this x alone. And so I'm going to subtract 3 from both sides. So that's going to give me e squared minus 3 equals 3x. And then again, I'm only trying to get this x by itself. So I'm going to divide both sides by 3. This is the problem where we kind of had two answers. We had an exact answer and we had a decimal approximation. And so our exact answer is going to be x equals e squared minus 3 over 3. So this is my exact answer, okay? Then they're going to say, all right, well, while you're at it, go ahead and give me the decimal approximation. And so we're going to have to type this into our calculator. Now, if you were one of the folks who had issues with typing this in, the answer we should get is 1.46, but let's make sure that you are getting it. Okay, so the first thing you're going to do is you're going to hit the E button. You're going to raise it to the second power. You're going to have to use your little arrow button or parenthesis, whichever, whatever type of calculator you have, to come down out of there. Then you're going to minus 3, and then you're going to hit enter. You'll hit some kind of a decimal, I don't know. Then you'll hit the division button, then you'll hit 3, then you'll hit enter again. And then that'll be what gives you this. Okay, so take a sec, make sure that you can type this in. And then we can move on, excuse me, we can move on to something else. And so while you guys make sure you type that in, I'll get a condensed problem here. Okay, so that we can, a couple of those, and make sure we can do that. All right, are we good on this one for now? 7.3 for now?
When you type it into the calculator, do you hit the LN button or do you have to hit the caret button? I mean, the second button to go up to the E.
You have to, when you type it in, you'll have to hit the second and then the LN button first, which is going to give you this E.
Okay, and then it's...
So look, I'm writing in orange in the middle of the screen. Does it have this? And then there's our little button here already? With like a parenthesis maybe? Is that what you see?
Yeah, caret's up and then it's a parenthesis start.
Okay, so then you're going to put the number 2.
Mm-hmm.
Then you're going to close parenthesis.
Okay.
Then you're going to hit minus 3. Then hit enter. Then hit divide by 3 and then hit enter again. And that should give you this guy.
Okay, I got it. I didn't hit enter the first time.
Okay, yep. That's why I'm trying to show you guys how to type these things in as well as solving them. Okay, so let's look at some condensing logs, okay? So that was the next question. So we are going to look at some problems where we condense. And when we talk about condensing, we're talking about going from many to one. Okay, that's the whole goal here. So what if I have, let's do the ln of 15 plus 2 ln of x minus 6 ln of y. And so obviously I have 3 logs, okay, many of them, and I need to condense this so that it becomes 1. And so what I'm going to do is I'm going to go from left to right. I'm going to look for numbers out front, nothing here. Oh, hey, look, here's a number. What do I know that, where did that come from? It was an exponent. Hey, look, another number. Where'd that come from? It was an exponent. So the first thing that I'm going to do is pull out any exponent. So this is going to turn into the ln of 15 plus the ln of x squared minus the ln of y to the 6th. Okay, any questions on that? Okay, so then I go back to the beginning and I read from left to right again and I say, okay, hey, look, a plus sign. What do I have to turn that into?
Multiplication.
Multiplication. And I say, hey, look, a minus sign. What do I have to turn that into?
Division.
Division. Okay, and so let's do that. And so we're going to turn this into the ln of 15 times x squared. And then we're going to divide that by y to the 6th. Whoops, hold on. My parentheses look really bad because I made them too small. And then that is going to be it. We went from many to one. We condensed. Done. Perfect. All right, let's try another one, okay? Just to make sure we can. How about, let's see, I don't want to make them too awful hard because I'm not trying to kill you guys on the test. I just want to make sure you have the rules down. So how about this one? How about we have log of x plus log of 15 plus log of z. Okay, and so first things first, we look out front and we don't see any whole numbers out here. So that means that none of them are going to turn into exponents. So that's good. And then as we read from left to right again, we see, hey, look, a plus sign, which means I'm turning it into multiplication. And hey, look, another plus sign, which means I'm turning it into multiplication. And so the stuff gets multiplied. And so this will be log 15xz. And now I think I mentioned to you guys before, these three pieces, as long as they're in there, they don't have to be in any certain order. Okay. You could have z, or you could have x, z, 15. It just looks weird to me if the whole number is not first, but it doesn't mean it's wrong. Okay, so condensing logs. What do you think? Better? I have a couple more, or we can try expanding them, or we could try something totally different, whatever you guys want. How about we do a couple expanding since we're just on the topic? So how about, let's get this thing cleared. So now we're going to expand. And when we do that, let's start with this one. Log base 8 of 64x to the third. Okay, so we go inside these parentheses and we say, okay, look, here's what's happening. 64 is being multiplied by x to the third. When we have something that's being multiplied and we're going to expand it, which means to go from one to many, we're going to turn the multiplication into addition. And so the first thing I'm going to do is rewrite this as log base 8 of 64 plus log base 8 of x to the third. And then I say, okay, now I have to go through and I have to try to simplify each piece as much as I possibly can. And so when we get to, remember what happens when we just have numbers? What do we have to check for? Anybody remember? Yeah. Okay, so Lakin's on it. So when we have just numbers, we have to ask ourselves, is there any possible way that this little guy down here could somehow turn into 64 by raising him up? The answer is yes. This is actually 8 squared. And so what we're going to do is we get to say that, you know what, based on the fact that 8 squared gives me 64, this whole entire thing just turns into the number 2. And then we keep going and we say, okay, this is not just a number, so we're okay, but oh, hey, look, we have an exponent. And when we have exponents, we can't leave them out there, so we have to bring it to the front. Okay, so Lakin, you're very close. This is going to become 3 log base 8 of x. And that's it. I'm done. So what do you guys think? Better, worse, questions, problems? Somebody say something.
Okay, I have a question. So like where it's base 8 and then 64, so when you get the 2, if it was like any other one, would it just be whatever the exponent is?
Okay, hold on. So you're talking about right here, right?
Yeah.
What do you mean if it would have been any other one?
Like you do, so 8 squared is just 64.
Yeah.
So 2, you're getting the, like, I don't know how to explain it.
So the number that I'm looking for is just the exponent, I think is what you're saying. So had this have been, let's say, the number 512, which is kind of large, but let's say it was 512. You would ask yourself, can 8 somehow turn into 512? The answer is yes. It's 8 to the third. This guy would have been a 3.
Okay, that's just, yeah, sorry.
Okay,
I just didn't know how to ask.
Yes, I thought that's what you meant. So yeah, that's the case. All right, anything else right now, or we can move on to something else. Okay. So what else, guys? Think about if you had to take the test right now, today, what is it that you're like, because that's what I need to help you with. Um, 7.1. Okay, let me get back there. Can you actually be just a teensy bit more specific on what exactly you want me to look at? Because there were several things in 7.1. So how about, let's see, maybe solving the, how about something that looks like this? Okay, what if we have 2 to the x plus 1, and that's equal to 64 to the third. Now, because she asked me to go to 7.1, this is before we knew about the ln. Okay, so let's not think about ln right now. This is when we took our bases and we try to make them equal. This is a base 2. I can't change a base 2, but this is a base 64. Is there any possible way that I could write 2 to the something and that gives me 64? That's what I need to ask myself. Is that possible? Well, it turns out that it is. Okay, it's going to be 2 to the 6th. So what I'm going to do is the left-hand side is going to stay the same, 2 to the x plus 1. This 64 is going to turn into 2 to the 6th. However, it's still being raised to the third. So now I have the same basis of a 2, and so I don't care about those anymore. And now I get to take my exponents, and I get to set them equal to each other. So I'm going to have x plus 1 equals, now over here, I have power to a power. And when I have power to a power, I have to multiply. So that's going to give me 6 times 3, 18. And then I have to subtract 1, and I'm going to get x is 17, and ta-da, done. Okay, Ashley, can you give me something else? Or is that what you kind of wanted, or what?
That's what I wanted, because I had the
Okay, you
trouble
wanna
with
do another
power
one
to a
like that?
power. Yeah.
Yeah, let's do another one. Okay, I'll leave that up there for reference, but let's do another one. So how about, let me get my black pen going here. How about, okay, how about 9 to the 2x minus 5 equals 27 to the x minus 2. So same idea, we're trying to get the bases to be the same, and then we are trying to get our exponents equal to each other. And so now we have 2 different bases. We have a 9 and a 27. And we want to know, okay, we always want to do the smallest base we can. We want to know, is there any way that the number 9 can be raised up and give me a nice, neat 27? Well, no. Okay, there isn't. And not nicely anyway. So we can't do that. So we have to look at number 9 and number 27. We have to say, hey, is there any other base that can somehow become 9? So is there a number that if we raise to a power equals 9, and that same number raised to a power equal 27? Yeah, like it's 3. Okay, so we're going to say, well, 3 to the what gives me 9? Just squared. And 3 to the what gives me 27? The third power. So what's going to happen is we are going to rewrite 9 as 3 squared, and we are going to rewrite 27 as 3 to the third. Oops. So let's do that real fast. So we will have 3 squared, okay, but it's still being raised to the 2x minus 5. That hasn't gone anywhere. The 27 we decided was 3 to the third, but again, that's still being raised to the x minus 2. And so now I have my same base of 3. And so I get to take these exponents and set them equal to each other. And since on both of these it's a power to a power, I have to multiply. So I'm going to have 2 times 2x minus 5 equals 3 times x minus 2. And now I get to kind of forget about all this nonsense, and I just have to solve this little guy. And so when I do that, I'm going to get 4x minus 10 equals 3x minus 6. I'll minus 3x from both sides, and I'll add 10 to both sides. And so when I do that, I will get x equals 4. And now I'm done. Ta-da. Okay, so now someone wants to take a look at the graphing. Okay, so let's do that. So let's see. Graphing. Which one do I want to do here? Okay, so when we talked about graphing, and remember, since someone specifically asked me to do this, is still 7.1. Right now we don't know about logs. So right now we're just graphing exponential functions. Okay, so expo functions. And we said that if a was greater than 1, it was an increasing function, and the intercept, y-intercept was 0, 1. And if a was less than 1, then it's a decreasing function. The intercept, though, is still 0, 1. And so what's going to happen is we're going to be given some things to graph, and all we have to do is look to see if there's any transformations. So we'll keep this up here and we'll try a couple just to see. So what if we have, I don't know, let's do f of x equals 2 to the x. Let's do it like that. And so the first thing that we need to realize is in this case, the a value is a 2, which is greater than 1. And so because of that, it's going to be increasing and it's hitting the point 0, 1 for sure. And then I say, okay, well, are there any other transformations happening over here? The answer is to that, no other transformations are happening. And so this is where I pick my x and my y chart. And remember, since we're just dealing with an exponential function, we choose the x values. Okay, we're not dealing with the log function, so we still choose the x values. So we're going to do 2 to the negative 1, 2 to the 0, and 2 to the first. So 2 to the negative 1, 1/2. 2 to the 0, 1. 2 to the first, 2. So I'm going to have 1/2, the number 1, the value 2. And so now, since there are no other transformations, I'm ready to graph this thing. And so when I do that, let's see. I'm going to go over to negative 1 to the left and then up 1/2. So about right here, I'd say. And then the y-intercept of 0, 1, so about right here. And then the point 1, 2. And again, I know in my mind that what it's supposed to look like. It's supposed to be an increasing curve like that. So it doesn't cross the x-axis. So it comes up like this. And just like that, I'm done. Now, what are your thoughts? That's just a nice, neat, basic parent function. Nothing's happening. Any issues with that? Yeah, we'll do a bigger one. Is it okay, Sydney, if I just build on this one so we can leave the stuff that we have? Okay, so let's pretend, and I'll do it in a different color so that we can see it. So let's pretend that we have the same problem, but let's say that it was given to us that it's going to be x, I don't know, let's do minus, oops, sorry. Let's do x minus 3, and then out here, let's do a big plus 1. Okay, so this is my new function. Okay, so let me get rid of a few things here, just so we have some room. And the purple function that I've already drawn, I'm going to leave it there because that's our base parent function. We know that's what it looks like before any transformations happen. Okay, so my a was a 2. Okay, so we still know that in this case, a is 2, which was still greater than 1. And so we know that it's still going to be an increasing function. 2 is greater than 1. And it's still, the parent function is still going through 0, 1. That's this purple function. Okay, now, when we look back over here, so I'll underline it. That's our purple function. When we look back over here, we have to ask ourselves, okay, are there any other transformations happening to this graph? Well, I see this. What does that minus 3 tell me? I got to go right 3. Good. And then I say, okay, well, what else do I see happening? And I see this big plus 1. So that big plus 1 tells me to go up 1. All right, now, if the y-intercept was right here at 0, 1, okay, because that's where it was. So let's start with that. Let's start with 0, 1. We'll write this down. Now, the first thing that happens is I'm going right 3. So if I start at 0, 1 and I go right 3, where am I at now? What point am I at now? Well, I'm at the point 3, 1. Do you agree? If I started here and I went right 3, I'd be at the point 3, 1. Okay, so then now we're going to say, all right, well, the next thing that happens is I'm going up 1, right? So if I start at the point 3, 1, and I go up 1, where am I at now? Well, aren't I at the point 3, 2? Okay, So what's going to happen is the new point where I start or where I draw my line through is going to be the 0.32. So let me get rid of some of these dots. So I go to the right 3, and I'll go up 2, and here's my new point. And I already know what it's supposed to look like. Now remember, when you do this test, since you are doing it in Hawks, they're going to give you pre-made graphs. Okay, so they're going to give you 4 graphs, and maybe they look like this. So maybe here's one. Okay, and I'm just quickly doing this. Maybe here's one. Maybe here's one that looks like this. I don't know. And then maybe finally, here's the one that goes through the 0.32. And you might have to count. And let's say it looks like this, okay? Because that's what ours is going to look like. What's going to happen when you're doing the exam is you have to be able to find this new point. That is the most important thing. Okay, because once you find that new point in your mind, you already know, hey, the graph should be increasing, so you can just do a real quick rough draft like that. And then you can come down here, and it's going to be super easy for you to pick the right graph based on the point. So finding this point is the key. So what do you think? Just give me a rough draft of what you've of the one that you picked on your paper. Because what's going to happen, as you guys know, once you turn your exams in, I go through and I check all of it by hand, okay, each question, which is why it takes me so long. And I say, okay, well, they didn't do any work. They have no idea. They just guessed. I don't know. But if I see some stuff that looks like this over here, that's what I need to see. I need to see on your paper you having found this point. And then you can go in Hawks. You can say, oh, it's this graph. And then on your paper, you'll just put a really quick rough draft of that. You'll just draw it real quick for me. Does that help clear it up?
Yeah,
Yes.
because I was wondering how to show work for these for you.
Yeah, so let's pretend this was the exam, okay? What I'm about to circle in yellow is exactly what I would like to see on your paper. Obviously, I need you to write the equation so I know what I'm looking for, okay? I would like to see this so that I know that you know the rules, so to speak. All that work that we had right here in words, up, down, left, right, make sure you do that for me. So this what was right 3, up 1, and then this point, because you know if you start at 0, 1 and you go right 3 and up 1, you're going to be at this point. Everything circled in yellow is what I would like to see. And then once you determine this point, you'll come over here to where your graphs are found. You'll circle the one that you want. Just go like this on your paper. So I know that you chose the right one. That's it. Okay, so we're not going to overcomplicate this. Just give me as much work, excuse me, as you think that you need.
Okay.
All right, so there's a graphing one. What else? So today and tomorrow, we can meet for as long or as short amount of time as we need. So if you guys, and I'm not saying I'm leaving, but if you don't have any questions for me, I'm not gonna just keep berating you with problems. I think that you have enough work to do, and I've given you a bunch of practice stuff, and I can't imagine that you've completed it all yet, okay? So whenever you guys are done, you say, man, I just gotta go work on my stuff, then we'll be done. So if that's now, fine. If it's not now, fine. So what else? Anything else at all? Otherwise, I'm just gonna let you guys go. You guys know how to prepare for one of my exams. You know the reviews out there. You know, tomorrow we'll go over that review. So whatever you need to do is fine by me. Okay, Sydney, then good to go. Anybody else want to talk or ask me questions or show me anything at all? If not, I mean, we're done then. Just whatever you guys want.
I think I'm good.
Okay, yep, tap out anytime you need to.